This is Chapter 5, Section 5.1 on the fundamental identities. This is one of my favorite chapters in the book because you can be a little more creative in the ways that you solve these problems, and sometimes one way may not work, and so you try a different way until you can get to the answer. So that's not with all the problems in this chapter, but many of them are like that. Do you remember what an identity is? An identity is an equation that is satisfied by every value in the domain of its variable. We worked with this back in Appendix A when we were solving equations, and when you would come up with a true statement, something like 5 equals 5, then you knew that equation was true for all values of x. Well, this is the same idea. The equation is satisfied by every value as long as it's in the domain. Let's review a little bit. With the fundamental identities, we've seen all of these before, so we'll just write them down really quickly. The first set are the reciprocal identities. So remember how cotangent is the reciprocal of tangent. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. The quotient identities. Tangent is sine theta over cosine theta, and cotangent is a reciprocal of that, so it's cosine theta over sine theta. And then the third set are the Pythagorean identities. Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. And 1 plus cotangent squared is cosecant squared. We learned all of those in the first chapter. And then we worked with even and odd identities back then, and also in chapter 4 when we were drawing the graphs. 4 of these functions are odd. Sine is odd, and so sine of negative theta is equal to negative sine of theta. Cosecant is also odd. And then tangent is odd. Plug in a negative theta, you get negative tangent theta, and so is cotangent. But then cosine and secant, those two are even. So they're even functions. Cosine of negative theta is cosine of theta, and secant of negative theta is secant of theta. Also in chapter 1, you were asked to find alternative forms of the fundamental identities. And so an example is if we had sine squared plus cosine squared is equal to 1, we could solve this for sine squared, or we could solve that equation for cosine squared. So you'll want to remember alternative forms when you are working with identities. Going on to page 2, so 5-2, in the middle, after example 1, it says, when taking the square root, be sure to choose the sign based on the quadrant of theta. Remember when you're solving equations and you use the square root property, so you end up having plus or minus the square root of something? That plus or minus will be based on whatever the quadrant of theta is.